The valleys of Kunar province in Afghanistan are known for their silence. It is a heavy, anticipatory silence, broken only by the wind moving through the high passes and the occasional rattle of loose rock. But on a clear day in the mid-1980s, that silence was shattered by a sound so alien, so deafening, that it stopped a Soviet convoy in its tracks and sent Mujahideen fighters scrambling for cover. From the valley floor, a scream erupted. It was the distinct, high-pitched whine of a jet engine, the kind usually heard on a runway or high in the troposphere. But this sound wasn't coming from the sky. It was coming from the ground. As the noise intensified, the shock waves began to reverberate off the canyon walls, shaking dust from the rocks and vibrating in the chests of every soldier within a mile. To the observers on the ridgelines, it looked like a monster. Through the heat haze and the rising dust, they saw a tank chassis, familiar enough in this war. But mounted on top, where a turret should be, was something grotesque. A massive, cylindrical engine pod, roaring with fire and fury. As it moved slowly forward, a blast of superheated air erupted from its front, tearing up the road surface, scattering stones like shrapnel, and enveloping the machine in a cloud of debris. The immediate reaction was confusion. Western intelligence officers monitoring radio traffic intercepted frantic reports of a new Soviet superweapon, a flame tank, or a sonic cannon. The Mujahideen, hardened fighters who had seen tanks and helicopters, had no frame of reference for this. In warfare, the unknown is always terrifying. The psychological asymmetry was profound. If you don't know what it is, you assume it can kill you in ways you haven't imagined yet. But this machine was not a secret weapon designed to burn enemies alive. It was the Progrev-T, a gas-dynamic minesweeper. It represents one of the most extreme examples of engineering improvisation in military history. It was a mismatch between technological brilliance and the brutal reality of the battlefield. A jet engine strapped to a tank, sent to clear mines with pure, raw power. To understand why this strange beast existed, we have to look beyond the spectacle. The Progrev-T is a case study in innovation under pressure. It tells us what happens when engineers are given an impossible problem and solve it with the only tools they have left: brute force and imagination. The story of the Progrev-T begins long before the mountains of Afghanistan. It starts in the planning rooms of the Cold War, where Soviet generals were wrestling with a problem that threatened to paralyze their entire offensive doctrine: the minefield. In the decades following World War II, NATO's defensive strategy in Europe relied heavily on depth. They knew they couldn't match the sheer number of Soviet tanks, so they planned to slow them down. They built layers of defense, and key to those layers were dense belts of anti-tank mines. Millions of mines were stockpiled, ready to be sown across the plains of Germany at a moment's notice. For Warsaw Pact planners, this was a nightmare. Their entire strategy was built on speed and momentum. They needed to punch through NATO lines quickly before American reinforcements could arrive across the Atlantic. A minefield is a tempo killer. It forces an army to stop, deploy sappers, and clear a path under fire. Every hour spent clearing mines was an hour the enemy could use to regroup and counterattack. The core strategic problem was simple but brutal. How do you breach a minefield quickly without sacrificing hundreds of engineers and slowing down the advance? Traditional mine-clearing methods were inadequate for the speed of modern war. The most common tool was the mine roller, like the KMT series. These were heavy steel wheels pushed in front of a tank. They worked by triggering the mines with their weight. But rollers were slow, heavy, and often damaged by the explosions they caused. They were sacrificial components that needed constant replacement. Manual clearance, sending men out with probes and metal detectors, was effective but suicidally slow. In a high-intensity conflict, with artillery falling and machine guns firing, it was not a viable option for a breakthrough. Line charges, rockets towing a string of explosives, were fast and effective, but they only cleared a narrow path. They were also logistically constrained. You could only carry a few, and once they were used, you were out of options. The Soviet planners wanted something different. They wanted a solution that didn't rely on contact. They wanted a system that could sweep a wide path, continuously, without stopping to reload or replace broken wheels. They wanted a non-contact solution. And in the 1960s, the Soviet Union was in love with jet engines. They were putting them on everything: trains, boats, and even snowplows. It was a time of boundless technological optimism. If a jet engine could propel a fighter plane at twice the speed of sound, surely it could blow a few mines out of the ground. Thus the idea was born. Mount a jet engine on a tank chassis. Use the sheer force of the exhaust to blast the soil away, expose the mines, and maybe even detonate them with the heat. It was a concept of elegant violence. But as we will see, turning a jet engine into a minesweeper involves a collision with the laws of physics that even the most powerful turbine cannot easily win. The concept was simple. Take the chassis of a standard T-55 tank and mount not one, but two R-11 jet engines on top. The R-11 was the power plant of the legendary MiG-21 fighter, a sleek, supersonic machine known for its speed and agility. Now, these engines were being repurposed for a completely different mission: tearing up the Earth. This hybrid beast was designated Object 604. The engineering hypothesis behind this strange creation was rooted in the sheer physics of jet exhaust. A jet engine produces a stream of gas moving at hundreds of meters per second. The temperature of this exhaust can reach 800 to 900 degrees Celsius, over 1,500 degrees Fahrenheit. The mass flow is enormous, thousands of pounds of air per minute being compressed, heated, and expelled. Soviet engineers reasoned that if they directed this inferno at the ground, it would act like a gigantic continuous explosion. The high-velocity gas would strike the soil, creating a zone of intense pressure and turbulence. It would shear the top layer of earth away, exposing any mines buried beneath. The sheer force would physically blow the mines out of the ground or trigger their pressure plates. And if the mines were heat-sensitive, the scorching exhaust might detonate them prematurely. The goal was ambitious: to clear a path 4 meters wide, enough for a tank column to pass through safely, at a speed that would keep pace with an armored advance. On paper, it looked like the perfect solution to the minefield problem. It was fast, it was continuous, and it didn't require sacrificial rollers or vulnerable sappers. But physics is rarely so cooperative. The engineers soon discovered that the interaction between a supersonic gas jet and the ground is incredibly complex. The impact creates a phenomenon known as gas dynamic impact. The jet exhaust generates high stagnation pressure where it hits the surface. This pressure tries to push the soil down and away. At the edges of the jet, shear forces tear at the surface, lifting particles and debris into the turbulent flow. However, soil is not a uniform material. Dry sand behaves differently than wet clay. Rocky terrain diffuses the energy of the jet, while soft mud absorbs it. In testing, Object 604 struggled with cohesion. Wet clay resisted displacement, clinging stubbornly to the ground despite the hurricane-force winds battering it. The jet could blow away loose dirt, but it couldn't easily penetrate compacted earth. Furthermore, the assumption about detonating mines with heat proved to be flawed. Most anti-tank mines are pressure-activated. They are designed to trigger when a heavy vehicle rolls over them. They are not primarily heat-triggered. While extreme heat can weaken the casing or melt the explosive filler, it rarely guarantees a detonation. A mine might survive the heat blast intact, only to explode later under the treads of a following tank. This was a fundamental misunderstanding of the target. You can't just cook a minefield, you have to crush it or remove it. The jet engine could expose the mines, but it couldn't reliably neutralize them without physical contact. There were other problems too. The fuel consumption of two R-11 engines running at full throttle at ground level was staggering. A jet engine is designed to operate efficiently at high altitude and high speed, where the air is thin and cold. At sea level, in dusty conditions, it gulps fuel at an unsustainable rate. The operational range of Object 604 was pitifully short, perhaps only a few kilometers before it needed refueling. The engines themselves suffered. Jet turbines are delicate machines with tight tolerances. They suck in massive amounts of air to run. On a clean runway, this is fine. In a cloud of dust and debris kicked up by their own exhaust, it was catastrophic. The engines ingested dirt, rocks, and sand, which rapidly eroded the compressor blades and clogged the internal passages. The lifespan of an R-11 engine on a tank was measured in hours, not thousands of flight hours. By the late 1960s, the project was quietly shelved. The cost per kilometer of cleared path was simply unacceptable. The logistical burden of fueling and maintaining the jet engines was too high, and the tactical niche was too narrow. It worked great on dry, loose soil, but failed on anything else. Object 604 became a footnote in Soviet military history, a weird experiment that didn't quite work. But ideas in the Soviet Union rarely die completely. They just go into hibernation. 2 decades later, a different war in a different landscape would change the equation. The mountains of Afghanistan presented a new set of challenges, and the old idea of the jet-powered minesweeper was about to be dusted off and given a second chance. 2 decades after Object 604 was shelved, the Soviet Army found itself in a very different kind of war. The conflict in Afghanistan was not the fast-paced, armored breakthrough across the plains of Germany that planners had envisioned. It was a grinding counterinsurgency fought in treacherous mountain terrain. The supply lines were the lifeblood of the Soviet effort, stretching for hundreds of kilometers through narrow passes and winding roads. These supply routes were critical for logistic survival. Convoys of trucks and armored vehicles carried everything from ammunition to food to fuel. But they were also incredibly vulnerable. The Mujahideen, masters of guerrilla warfare, quickly realized that the easiest way to strangle the Soviet war machine was to attack its arteries. They focused their sabotage efforts on the asphalt sections of the roads, burying mines under rubble, hiding them in potholes, or disguising them as rocks. The environment in Kunar province and other mountainous regions resembled a controlled linear strip, a perfect corridor for ambush. But it also resembled something else, an ideal runway for a jet engine. The roads were often paved, straight, and confined by the terrain. This was not the open field of Europe where a jet blast would dissipate. Here, the exhaust could be focused and channeled. Thus, the Progrev T was reborn. It was a simplified, more rugged version of the earlier concept. Instead of the delicate, high-performance R-11 engines from the MiG-21, engineers chose the robust VK-1 turbojet engine from the older MiG-15. The VK-1 was a proven workhorse, simpler and more tolerant of abuse. A single engine was mounted on top of a T-54 tank chassis, angled slightly downward. The goal was to clear a path 10 to 12 meters wide, enough to sweep the entire road surface and the shoulders where mines might be hidden. The theory was that the jet blast would blow away the loose debris covering the mines, expose the disturbed earth, and potentially detonate any heat-sensitive explosives. It was a brute force solution to a nuanced problem. When the Progrev T roared into action, the physical effects were undeniable. The jet exhaust hit the road surface with the force of a hurricane. It tore up asphalt that had been weakened by frost or sabotage. It sent gravel flying like bullets. It displaced rocks the size of melons. The mines themselves were often physically ejected from the ground. The sheer kinetic energy of the gas stream could lift a heavy anti-tank mine and toss it aside. The dust plume created by the operation rose up to 20 meters high, a visible signal to everyone in the valley that something powerful was at work. It worked, in a sense. The road was cleared of debris, mines were exposed or triggered, but the cost of this success was staggering. The VK-1 engine is a thirsty beast. Designed to push a fighter jet to near-sonic speeds at altitude, it consumes fuel at an alarming rate. At ground level, running at full power to generate the necessary thrust for mine clearing, the engine burned approximately 3 tons of kerosene per hour. Let that sink in. 3 tons of fuel every 60 minutes. The standard internal fuel tanks of a T-54 chassis hold about 700 liters of diesel, enough to drive for 400 kilometers. The Progrev T carried additional fuel tanks on its deck, but even with this extra capacity, its operational range was pitifully short. A single fuel load might last for only 6 kilometers of continuous operation. That's less than 4 miles. In a convoy stretching for dozens of kilometers, the Progrev T had to stop constantly to refuel. This created a logistical nightmare. Fuel trucks had to accompany the minesweeper, exposing themselves to enemy fire. The convoy's speed was dictated not by the threat, but by the thirst of one machine. It was logistically unsustainable. The fuel consumption alone made the Progrev T a liability rather than an asset. But the problems didn't stop there. The noise produced by a jet engine at close range is deafening. We are talking about sound pressure levels of 130 to 140 decibels. This is louder than a gunshot, louder than a rock concert, louder than the threshold of pain. For the crew inside the tank, even with ear protection, the noise was physically exhausting. The vibration penetrated their bodies, causing fatigue and cognitive degradation. It is hard to think clearly when your entire world is shaking. For the soldiers in the convoy behind the Progrev T, the constant roar was a psychological strain. It masked the sound of incoming fire or approaching enemy vehicles. It made communication difficult. The long-term hearing risk was severe. But in war, long-term health is often sacrificed for immediate survival. The human endurance factor, the ability of the crew to operate effectively in such a punishing environment, became a critical limitation of the system. A weapon is only as good as the men who operate it, and the Progrev T was pushing its operators to the breaking point. Turbojet engines are marvels of precision engineering. They rely on clean air to function properly. They have tight clearances between the compressor blades and the casing. They are designed to operate in the thin, cold air of the upper atmosphere. Afghanistan provided the exact opposite environment. The air was thick with fine silica dust, essentially powdered glass. The ambient temperatures in the summer could soar well over 40 degrees Celsius, 100 degrees Fahrenheit. The engine was running under high load, sucking in hot, dirty air. The result was predictable. The engine lifespan collapsed. The compressor blades eroded rapidly, losing their efficiency. The internal components clogged with dust and melted sand. An engine that might last hundreds of hours on a MiG-15 was failing after only a few dozen hours on the Progrev T. Maintenance became a nightmare. Spare parts had to be flown in from the Soviet Union. Specialized technicians were needed to repair the delicate turbine machinery. The operational downtime was severe. For every hour the Progrev T spent clearing mines, it spent many hours in the repair depot. The machine was brilliant in concept, but flawed in execution. It was a technological gamble that failed to account for the harsh realities of the Afghan environment and the limits of human and mechanical endurance. The Progrev T was designed to solve the problem of minefields slowing down an armored advance. But in practice, it became the very bottleneck it was meant to eliminate. The speed of a jet engine clearing mines is deceptive. While the exhaust moves at hundreds of meters per second, the vehicle itself crawls. To effectively scour the road surface and detonate hidden explosives, the tank had to move at a snail's pace, typically between 1 to 3 kilometers per hour. Imagine a Soviet convoy stretching for miles through a narrow mountain pass. At the front, the Progrev T inches forward, blasting the road with fire and noise. Behind it, hundreds of trucks, armored personnel carriers, and tanks are forced to wait. The entire column becomes a stationary target. For the Mujahideen, observing from the high ridges, this was a gift. A halted convoy is an easy target. They could set up ambushes at their leisure, knowing exactly where the Soviets would be stuck. The predictability of the minesweeper turned the convoy into a sitting duck. Instead of speeding up the advance, the Progrev T dictated a tempo that was agonizingly slow and dangerous. The effectiveness of the Progrev T was strictly limited by geography. It worked best on paved, straight segments of road where the jet blast could be focused and controlled. In the flat plains of Europe, this might have been acceptable. But Afghanistan is a land of winding mountain roads, steep inclines, and rough terrain. On soft ground, like mud or loose sand, the heavy tank chassis struggled for traction. The recoil from the jet engine pushed the vehicle backward, fighting against its forward momentum. On curves, the fixed jet nozzle couldn't sweep effectively around the bend without meticulous maneuvering. And on steep slopes, the angle of the jet blast changed, either digging too deep into the road or shooting harmlessly over the top of the mines. The machine was essentially a specialized tool for a specific type of road. In the chaotic, varied landscape of war, such specialization is a liability. If the convoy encountered a dirt track or a rocky riverbed, the Progrev T became useless dead weight. Perhaps the most significant tactical flaw was the complexity of the clearance process itself. Traditional mine rollers, like the KMT series, are simple. They roll over the ground, and if there's a mine, it explodes. It's a single-pass solution. The Progrev T introduced a multi-step chain. First, the jet blast would expose or disturb the mines. Then, the crew, or a following team of sappers, had to visually identify the threat. Was that dark shape a rock or a mine? Was the disturbed earth hiding an explosive? Once identified, the mine had to be neutralized. Sometimes the heat of the jet would detonate it, but often it wouldn't. This meant stopping the entire operation while a sapper went forward to deal with the device manually. This sequence, blast, look, diffuse, was inherently slower and more complex than simply running a heavy roller over the problem. It increased the cognitive load on the operators and added layers of potential failure. Instead of simplifying the mine clearance process, the Progrev T had complicated it. Despite its many flaws, the Progrev T did achieve one thing. It terrified the enemy. When the machine first appeared in the valleys of Kunar, the Mujahideen had never seen anything like it. The sight of a tank belching fire and screaming like a banshee was shocking. Rumors spread quickly of a new Soviet superweapon capable of burning fighters alive or destroying entire villages with sound. For a brief period, this psychological impact was real. Insurgents withdrew from areas where the Progrev T was operating. They hesitated to engage convoys led by the roaring beast. The sheer strangeness of the weapon created a tactical pause. But insurgencies adapt quickly. The initial shock wore off as fighters realized the limitations of the machine. They saw how slow it moved. They saw how often it broke down. They realized that while it was loud and scary, it was just a specialized mine-clearing tool, not a death ray. Once the pattern was recognized, the Mujahideen changed their tactics. They stopped planting mines directly in the path of the Progrev T. Instead, they mined the shoulders of the road, further ahead where the jet blast wouldn't reach. They targeted the fuel trucks supporting the minesweeper. They used the predictability of the slow-moving convoy to their advantage. The fear decay curve was steep. What started as a weapon of terror quickly became just another piece of Soviet hardware to be destroyed or avoided. The psychological advantage, like the tactical one, was fleeting. It is a strange twist of history that the Progrev T, a failure as a weapon of war, found its true calling in peace, or rather, in a different kind of war, the war against fire. The core technology, using a jet engine to create a high-velocity stream of gas, was adapted for civilian use in the form of the AGVT, Aviation Gas Dynamic Extinguishing Systems. These vehicles, often built on heavy truck chassis like the ZIL or Ural, used the same principle but added a critical element: water. By injecting water into the jet exhaust, the system created a massive cloud of mist, moving at hundreds of miles per hour. This high-momentum gas-water mix could physically disrupt a flame column, cutting off its oxygen supply and cooling the fuel source instantly. The most famous application of this technology came in 1991, during the Gulf War. Retreating Iraqi forces set hundreds of oil wells on fire in Kuwait. Traditional firefighting methods were too slow to handle the scale of the disaster. Enter the Big Wind. Based on a T-34 tank chassis, this Hungarian-designed machine mounted two MiG-21 jet engines. It was essentially a Progrev-T built for fire. It roared into the desert, blasting the oil fires with water and jet exhaust. It extinguished wells in minutes that would have taken days for conventional crews. Why did it work here when it failed in Afghanistan? The variables had changed. In mine clearing, the target, mines, is distributed and hidden. In oil fires, the target is fixed and visible. In war, the operation must be continuous and mobile. In firefighting, it is a series of short bursts at specific locations. Fuel cost in war is a critical constraint. In an oil field fire, fuel is irrelevant compared to the cost of the burning well. The terrain in Kuwait was static. The wellhead didn't move. The terrain in Afghanistan was variable and treacherous. Logistics in combat are constrained by enemy action. Logistics in a planned firefighting operation are secure. The problem was different, but the physics were the same. The jet engine provided the raw power needed to overcome the fire. The Progrev-T had been trying to solve the wrong problem with the right tool. When applied to fire, the brute force of the jet engine was exactly what was needed. The story of the Progrev-T is more than just an anecdote about a weird tank. It is a repository of hard-earned lessons about the nature of military innovation. When we analyze its failure in Afghanistan and its success in Kuwait, several strategic truths emerge. First, over-engineering risk. The Progrev-T was a masterpiece of raw power. It took the most powerful engine available and strapped it to the toughest chassis. But raw power does not equal an optimal solution. Sometimes, a simple, dumb solution, like a mine roller, is better because it is reliable and cheap. Complexity is a cost that must be justified by performance, and in the harsh environment of war, complexity is often the first thing to break. Second, environmental mismatch. Technology does not exist in a vacuum. It must match the terrain, the climate, and the doctrine of the force using it. A jet engine is designed for the sky, not the dusty, rocky ground of Kunar province. The failure to account for the specific environmental conditions, the dust, the heat, the fuel consumption at low altitude, doomed the project. A weapon that works on a test range in Russia may fail catastrophically in a mountain pass in Afghanistan. Third, logistics over innovation. In the long run, supply chains determine victory. A weapon that consumes fuel faster than it can be resupplied is a liability. The Progrev-T was a logistical black hole. It required specialized fuel, spare parts, and technicians that strained the already stretched Soviet supply lines. Innovation that ignores logistics is just an expensive hobby. Fourth, human factors matter. We often focus on the machine, armor thickness, engine power, gun caliber, but we forget the crew. The noise, vibration, and fatigue caused by operating a jet engine at close range degraded the performance of the human operators. Crew survivability and endurance are force multipliers. If the crew is deafened and exhausted, the machine is useless. Finally, adaptation pathways. The failure of a military technology doesn't always mean the concept is flawed. It might just be misapplied. The transition of the jet blast concept from mine clearing to firefighting shows that innovation is rarely a straight line. Failed military tech can find a second life in the civilian sector, solving problems it was never originally designed for. The big wind saved billions of dollars in oil and prevented an environmental catastrophe using the same physics that failed to clear mines in Afghanistan. So, was the Progrev-T absurd? It is easy to look at pictures of it, this Frankenstein monster of a tank and a jet, and laugh. It looks like something a child would draw. But to dismiss it as a joke is to miss the point. The Progrev-T was technically imaginative. It solved a theoretical problem, how to clear mines without contact, in a novel way. It was logistically reckless, burning fuel at an unsustainable rate. It was tactically constrained, limited to paved roads and slow speeds. And it was strategically misaligned, a Cold War solution applied to a counterinsurgency war. But it was also a testament to the Soviet ability to improvise. Faced with a deadly threat to their supply lines, they didn't wait for a perfect solution. They built something with what they had. They took a tank engine and a jet engine and welded them together. It was ugly, loud, and inefficient, but for a brief moment, it worked. It solved a theoretical Cold War problem. It partially addressed a tactical bottleneck in Afghanistan. But it could not survive the economic and environmental realities of war. Its legacy lies not in the minefields of the Hindu Kush, but in the oil fields of Kuwait. It is a reminder that sometimes the most powerful tool in the arsenal is not the one that kills, but the one that saves. The Progrev-T started as a weapon of war and ended as a weapon against destruction itself. As we look back on this strange machine, we see the reflection of a superpower stretching its technological limits, trying to engineer its way out of a quagmire. It failed, but in its failure, it left us a fascinating story of ambition, physics, and the stubborn persistence of innovation. The scream of the Progrev-T may have faded from the Afghan valleys, but the echo of its lesson remains. In war, and in engineering, context is everything. When the dust finally settled in the valleys of Kunar, the Progrev-T was left behind, a rusting monument to a war that couldn't be won with brute force alone. It sits in the memory of those who saw it as a symbol of Soviet excess, a machine that screamed louder than it bit. But if we look closer, we see something more profound. We see the universal human drive to solve problems with the tools at hand. The Soviet engineers didn't have advanced ground-penetrating radar or autonomous mine-hunting robots. They had tanks and they had jet engines, so they combined them. It was an act of desperate creativity. The story of the Progrev-T challenges us to think about how we define success in technology. Was it a failure because it didn't clear mines efficiently? Yes. But was it a success because it paved the way for the firefighting vehicles that saved Kuwait? Also yes. Innovation is messy. It involves dead ends, weird prototypes, and magnificent failures. Sometimes, you have to build the monster to learn why monsters don't work. You have to push the limits of physics and logistics to find the boundaries of what is possible. The Progrev-T pushed those boundaries until they broke, and in the breaking, it taught us lessons that are still relevant today, in an age of drones and cyber warfare. It taught us that the most sophisticated technology is useless if it can't survive the dust, the heat, and the chaos of the real world. Thank you for spending part of your day with us to explore this strange chapter of military history. If this story of jet engines, tanks, and the unintended consequences of innovation resonated with you, we'd be honored to have you with us again.